Okay, we're looking at a new system here. We have a planet orbiting a star and then moons orbiting the planet. We're really interested in the part where the moons orbit the planet here. So the first pair of moons are the same radius, the same distance away, but one has twice the mass of the other. They start out exactly opposite. So the question is, will the heavier moon orbit with a faster or slower period compared to the other ones? So basically, are they going to stay in this alignment, or is the 2m going to catch up, or is it going to lag behind and the m will catch up? Well, if we look at the forces on this, g times the mass of the moon there, which I guess we call 2m, over that radius squared is m, the mass of the moon, times 4 pi squared times the radius over the orbital period squared. So very quickly, the mass of the moon will cancel out. Oops, this should be a 2m as well, because that's also, right? So whatever that mass is, be it m or 2m or something else, it's going to cancel out because it's in both the gravitational force and the other. So basically, this is a question of, does acceleration depend on the mass of the falling object? And the answer has always been no. Things in orbit are in free fall, just like things that fall to the ground or fly through the air. It's just that they're going fast enough that they never quite reach the ground, but they're still in free fall. So we'll have the same delta t and the same v and everything, and they would just go around opposite the planet forever. The third moon is much further away, and so we want to know whether its orbital speed will be greater than, slower than, or the same as. So if we look at the forces again, it's the same force diagram, but I'm going to use the other expression for speed, or for acceleration, v squared over r instead, because that's what I'm interested in, and I'll solve for v. So we'll get gm over r square root. So in this case, the radius of this orbit is bigger, and this is the mass of New Caprica, which is the same for everything orbiting. So when the orbital radius is bigger, the orbital speed is slower.